All right, so the form of complex number is written as in what form? A plus bi. All right, a plus bi. So any number written in the form a plus bi. Okay, so that will be a complex number. And we dealt with complex numbers last class period. So for example, if you want to multiply, let's say you had 7 minus 2i. So notice that's a complex number. It's in the form a plus bi. And remember, the a is called the real part, and b is called the imaginary part. Real part, imaginary part. All right, so let's suppose we had 7 minus 2i times negative 6 plus 5i. All right, made that up. All right. We did this in the last class period. So to multiply those two complex numbers, what did you use? FOIL method. Okay, FOIL. So you said 7 times negative 6, the first? Negative 42. All right, then the outer, the terms on the outside. So what's 7 times 5i? 35i. And then the inner? Positive or negative? Positive 12i, right? And then the last. So I have a negative 2i times a positive 5i. What's that? Negative 10i squared. All right, so we talked about that. Now, we also know that I, the imaginary unit, is the square root of a negative 1. And so that's why we name it I, because the square root of a negative 1 is not a real number. So if you ever take the square root of a negative number in your calculator, you get an error. So we name it I, so it's imaginary unit. But we also know that I squared is equal to what number, though? Negative 1. So once you get to this point, you need to recognize that I squared is a negative 1. Okay, I squared is a negative 1. Now at this point, you can do this. You can combine like terms, so negative 42. Now what's this right here?
47i.
47i. And then what does this become? Plus 10. And then when you combine your constants, what do you get? Plus 47i. Okay? And then if it says write it in standard form is a plus bi. So is this in standard form? Yes, that's in standard form. All right, so that's what we did last class period. Now, what we're going to do, so here we multiplied, now you're going to divide. Now, before we divide complex numbers, we need to remember something from a previous course. So from a previous course, let's say you had 1 divided by 3 plus the square root of 5. 1 divided by 3 plus the square root of 5. Now, normally the directions for this one from the previous course would say rationalize the denominator. That's what it would say. So for this problem right here, we're going to rationalize the denominator. So in rationalize the denominator, what that means in the word rationalize is the word rational. So I'm going to ask you, do you see that square root of 5? You see there, is that a rational or irrational number? It's an irrational number. Square root of 5 is an irrational number. What you want to do is make this denominator a rational number. And see how this is a binomial? To make that denominator a rational number, not an irrational, but a rational number, you're going to multiply the numerator and denominator by the conjugate of 3 plus the square root of 5. All right, so you can rationalize the denominator. So you multiply numerator and denominator by the conjugate of 3 plus the square root of 5. Okay. All right, do you remember what the conjugate of 3 plus the square root of 5 is? It was a while back. Most of you probably forgot, but any of you remember? What do you think? 3 minus the square root of 5. So you just change that sign that's in the middle. So the conjugate of 3 plus the square root of 5 is 3 minus the square root of 5. All right? All right, so now I'm going to rewrite the problem. Oops, 3 plus the square root of 5. And we'll multiply the numerator and the denominator by the conjugate. Okay? Now remember, the whole purpose is to get rid of that square root that's in the denominator. I want to make it a rational number. Okay, so I'm multiplying these two numerators. 1 times 3 minus the square root of 5 is just 3 minus the square root of 5. Okay, so that one's easy. All right, let's look at the denominator. In the denominator, I'm multiplying, y'all can look at this as a binomial, right? 2 terms. So I'm multiplying 2 binomials. What are you going to do here? Foil. All right, so I'm going to go off to the side right here, and I'm going to multiply these 2 binomials. Now remember, keep in mind that those 2 binomials are conjugates, correct? So when we get into the complex numbers in a little while, you're going to remember that's the same idea here. They're going to be conjugates. All right, so let's FOIL. What's 3 times 3? 9. What's the outer?
Negative 3 square root of 5.
Negative 3 square root of 5. What's the inner?
3 square root of 5.
Positive 3 square root of 5, right? Okay, what's going to happen is if you notice that, and I'm not done, but if you notice at this point, what do you notice to be the outer and the inner? They cancel out. So the outer and the inner cancel out. And they cancel out because those are conjugates. So when you multiply 2 irrational numbers that are conjugates, the outer and the inner will cancel out. All right. Now, what is the square root of 5 times the negative square root of 5? Negative 5. Good. Negative 5. So remember in the previous course you learned this. The square root of 8.2 times the square root of 8.2 without using a calculator is just what? 8.2. That's what you learned in the previous course. That when you multiply 2 square roots and the radicands are the same, it's just a radicand. So the square root of 5 times the square root of 5 is just what? It's just 5. Now, you also learned this. The square root of 5 times the square root of 5. You all agree that's the square root of 25?
Yeah.
Hey, what's the square root of 25? 5. That's why it's just 5. Because when you multiply the radicands, it becomes a, well, if it's a whole number, it becomes a perfect square. And then this is just the square root of 25, which is 5. All right. Now let's combine like terms. These cancel out, right? And what's 9 minus 5?
4.
4. And notice this becomes a 4, right? So what kind of number is 4? Rational or irrational? It's rational. I'm done. I rationalized the denominator. That's all you did in the previous course. Now this is a review from a previous course. That's rationalizing the denominator. That same idea is going to be used with complex numbers. Okay? All right, so let's talk about complex numbers. All right, before we go on, remember the idea of conjugate. So I'm going to ask you this. The conjugate of the complex number a plus bi is what? A minus bi. Same thing we did a while ago with this irrational number. What's the conjugate of 3 plus square root of 5? 3 minus square root of 5. What's the conjugate of a plus bi? A minus bi. All right. So let's go ahead and divide. And let's suppose we had number 1, suppose we had 4 divided by 5 minus I. 4 divided by 5 minus I. And the idea is to get rid of that I. You don't want that I in the denominator. You don't want that I in the denominator. Because remember, I is that square root, right? I is the square root of what number? -1. Okay, so you don't want that square root in the denominator. So just like the previous problem, you're going to multiply numerator and denominator by the conjugate. What's the conjugate? 5 plus I, just like this. And so when you get that second worksheet, that's how you're going to do those problems in that second worksheet. Now in the previous problem, that was a 1 right here in the numerator. So 1 times this numerator is just that numerator, right? Now that's not a 1 though, so you have to think about what you're going to do. And what you have here is 4 times 5 plus I, right? So what are you going to do there? Distribute. So what does that become?
20 plus 4i.
20 plus 4i. So that's the numerator. All right. Now we got to multiply the denominator together. What will I use to multiply these two denominators? FOIL. What's 5 times 5? What's the outer?
Positive 5i.
Okay. What's the inner?
-5i.
And what should happen, since they're conjugates, what should happen? They should cancel out, and they do. A positive 5i and negative 5i is 0. And what's the negative I times a positive I?
-1.
Nope, nope.
Wait, no.
Go ahead and say it out loud. It's negative what?
I squared.
Negative I squared. I times I is what? I squared. All right, so you got to say that. You have to say negative I squared. But what is I squared?
-1.
-1. So I'm going to circle this. I'm going to circle this and put that as a -1. Now you got to be careful of this little part here. This becomes 25. Now minus a -1 is what? +1. Minus a -1, subtract a -1 is +1. So what do I get?
26.
26. So that becomes 26 right here. Okay, so that's where we're at.
So you don't want us to simplify that any further?
You mean this?
Yeah, I mean.
Well, I'm not done yet.
Okay.
All right, so that's where we're at. Okay, now, what I need you to recognize is I see this 20, the 4, and the 26. All right, well, first of all, let's think about what they're going to ask. They're going to tell you to write the answer in standard form. So standard form means A plus BI. So then if it says that, if it says write in standard form, then the next thing you're going to do is you're going to say, well, that's 20 divided by 26 plus 4i divided by what? 26. And then reduce. You need to reduce if you can. What's 20 divided by 26 equivalent to? 10 over 13. What's 4i divided by 26 equivalent to?
2i over 13.
2i over 13. So that was number 1. All right, number 2. Let's suppose you had this one. Let's suppose you had number 2. You had 6i divided by 3 plus 2i. 6i divided by 3 plus 2i. All right. So remember, you have that I in the denominator. You don't want an I in the denominator. So notice when I did this one, did I end up with a rational number in the denominator? Yeah. I have a rational number in the denominator. I is not there anymore. So what's the process you're going to use to get rid of that I that's in the denominator?
Multiply the numerator and the denominator by the opposite.
No, I don't use the word opposite, because the opposite of 3 plus 2i is where all the signs of the terms change. That's negative 3 minus 2i. That's not correct. So you don't multiply by the opposite of 3 plus 2i. You multiply numerator and denominator by the conjugate of 3 plus 2i. And what's the conjugate of 3 plus 2i? 3 minus 2i. All right, so then this becomes 6i divided by 3 plus 2i times 3 minus 2i, 3 minus 2i, just like this. So on the worksheet where it says show work, it's going to say show work for that. You got to show that. All right, so make sure you on the worksheet you mimic what we do in class. Okay, how are you going to deal with the numerators? Distribute. So basically you have this. You have 6i times 3 minus 2i, right? And for most of you, you really need to write this out. Don't do this in your head. What is 6i times 3? 18i. What is 6i times a negative 2i? Okay, so that's where I'm at. So you have to write this down so you can see it. What else are you going to do based on our previous experience? I squared. What's I squared? Negative 1. It'll be a positive 12 because a negative 12 times a negative I is a, negative 1 is a positive 12. So that's 18i plus 12. I'm going to go ahead and write it in standard form. What is it?
12.
Okay, so that's my numerator. So all I found at this point was the numerator. Okay, now let's deal with the denominator. So same idea, you're going to multiply the denominators together, but what method are you going to use there? In the previous, we used distributive property. Here I'm going to use what? FOIL. All right, so I get 3 plus 2i times 3 minus 2i. What's the first? 9. What's the outer?
6i.
What's the inner? What do you notice? What's supposed to happen? It's supposed to cancel out. And why are they supposed to cancel out? Because they are both conjugates. What is a positive 2i times a negative 2i?
Negative 4i squared.
Negative 4i squared. And what else must I remember?
2i.
I squared is negative 1. So this becomes 9 plus 4. A negative 4 times a negative 1 is a positive 4. So that becomes 13. Okay. Now remember, the directions will say write in the form a plus bi. It will say standard form, which means a plus bi. So what are you going to write the answer as?
12 over 13 plus 18 over 13.
Yep. All right. So that's what you do. Okay. Let's look at this one. Okay, so number 3. Number 3. Number 3, suppose we had four plus I divided by 2 minus I. 4 plus I divided by 2 minus I. Again, you want the denominator to not have I in it. So what are you going to do to get a rational number in the denominator? Multiply numerator and denominator by the conjugate. What's the conjugate of the denominator? 2 plus I. All right, so I get 4 plus I divided by 2 minus I, and then multiply the numerator and the denominator by the conjugate. Now, in both cases, when I multiply the numerators and when I multiply the denominators, I am going to have to use what method? FOIL. So write it out. Don't do this in your head. You're going to mess up probably at some point. I have to write out myself. Now, before I go on, just answer this question. When I FOIL this out, will the out and the inner cancel out? No, because those are not conjugates. Okay? All right. What's 4 times 2? 8. What's the outer? 4i. What's the inner? 2i. Notice they don't cancel. And what is the last? I squared. And remember, I squared is -1. So this becomes 8 and a what? -1, which is 7. And this becomes 6i. So that's the numerator. 7 plus 6i. All right. The denominator, I have 2 minus I times 2 plus I. Now those are conjugates, correct? So the inner will cancel out. All right. So what is 2 times 2? 4. Now we know that the outer and inner cancel out, right? So let's just not even write it. You can if you want to. But you know that they cancel out. If for some reason you're gonna think, well, I'm never gonna remember that, write it out. So the outer and inner will cancel out. Those are conjugates. So what's it? Let's do the last. What's a negative I times a positive I? So I'm leaving it off just to remind you that they cancel out, and you can leave it off. But what is I squared? -1. So this becomes 4 plus, not plus I, plus 1. That's where are you getting I from? You say I?
5.
Oh, 5. I'm sorry. Okay. All right. You see the denominator is now a rational number. So now write in the form a plus bi. Write in the form, the standard form. So it's the answer. Okay. So any questions? Y'all can do this. That's all this is. Okay. That's all this is.
What section is this?
This is 1.4. Still 1.4. Okay, and then let's do one real quick, one more. 7 minus 2i divided by 5 minus 3i. 7 minus 2i divided by 5 minus 3i. So you would divide those two complex numbers. Notice you don't want I in the denominator. In fact, you want the denominator to be a rational number. So what do I need to multiply numerator and denominator by? 5 plus 3i? Okay, so let's FOIL the numerator. All right, so in the numerator, I have 7 minus 2i times 5 plus 3i. What's the first? 35, is that right? What's the outer? 21i. What's the inner? And what's the last? Very good, -6i squared. But then you have to also remember that I squared is -1. So this becomes 35, and then what? What is this right here that I'm circling? -6 or plus 6? Plus 6. So what's 35 plus 6?
41.
Okay. And then what's a 21i and a -10i? And let's rewrite the numerator in standard form. So is this standard form? Yes. So that's my numerator. All right. The denominator, I have 5 minus 3i times 5 plus 3i. Those are conjugates, right? So it's going to happen with the out and the inner. So I'm not even going to write it. What's the first?
25.
25. What's the last?
Negative 6i squared.
Nope. 3 times 3.
9.
9. 9i squared. And remember, what else must you remember?
Negative I squared equals negative 1.
I squared is negative 1. So what does this become?
Plus 9.
Plus 9. So what is this?
36.
34. So what's the answer? Okay. All right. Any questions? All right. So on the worksheet, when you get the worksheet, you're gonna have problems like this, where you have to divide complex numbers. So just go over what we just did. Okay. All right. Now, let's look at this. So in my math lab, when you do this section, and I'm going to assign it today, when you do this section, you're also going to have problems like this. The square root of negative 49 minus the square root of a negative 25. Just go ahead and write this down. Square root of a negative 49 minus the square root of a negative 25. Now, we basically talked about something like that last class period. Just look at the square root of negative 49 for right now. Do you remember from last class period what this is? What's the square root of a negative 49 the same as? 7i. Good. 7i. Because remember, we talked about this. We said the square root of a negative 49 is the square root of a negative 1 times 49, right? Which, when you break it apart, is the square root of a negative 1 times the square root of 49. Right? And what's the square root of a negative 1? I. What's the square root of 7? Square root of 49? 7. So that's just 7i. So that was what we talked about last class period. So I get 7i, subtract. Now, what is the square root of a negative 25? 5i. Are those like terms? Yes. So what's 7i subtract 5i? 2i, and that's your answer. That's what you would write. Okay? Number 2, suppose I had this. 3 times the square root of a negative 144 plus 2 times the square root of a negative 81. So 3 times the square root of a negative 144 plus 2 times the square root of a negative 81. All right, let's deal with the square root of a negative 144, which is 12i. Good. So I'm going to write this as, and you could skip some of these steps here, but you're going to say 3 times 12i, right? Plus 2 times, what's the square root of a negative 81? 9i. So what's 3 times 12i?
36i.
What's 2 times 9i?
18.
Can I combine those? Use your calculator if you don't, can do this in your head. What's 36 plus 18? 54i?
Yeah.
All right, so that's number 2. All right. Okay, so let's kind of, before we go on with this, let's kind of review something. Now, the previous 2 were fairly easy because if you forget about the negative, 49 is a perfect square, 25 is a perfect square, 144 is a perfect square, 81 is a perfect square, right? All right, so you knew those were perfect squares, and the square root of a perfect square is just a whole number. 7, 5, 12, 9. They're not always perfect squares, though. So you got to remember what we did in the past. So let's review this. So suppose I want you to simplify the square root of, let's say, 18. Square root of 18. First of all, is 18 a perfect square? No, 18 is not a perfect square. No whole number times itself is 18. It's not a perfect square. But we can simplify this because there is a perfect square besides 1 that goes in 18. Last class period, we listed out perfect squares. So remember the notes, they're in your notes. I copied the notes if you need them. What perfect square besides 1 will go into 18? 9, very good. And what you did in the previous course was you said this. You said, well, that's going to be the square root of 9 times 2, right? And if you think about what we did earlier, see where I wrote this as -1 times 49? And then I broke it as 2 square roots? So what does this become? No, but say square root first. Square root of 9 times the square root of 2. Now you can do this in your head, but I wanted you to write it like we did this one. What's the square root of 9?
3.
So that's 3 what? Square root of 2. So the square root of 18 simplified is 3 square root of 2. Okay? All right, let's review one more. Suppose I had the square root of, let's say, 32. Now I'm using 32 because there are a couple of perfect squares. There are several perfect squares that go to 32 besides 1. There's what?
4.
4. And there's what? 8's not a perfect square. I'm glad you said 8. 8 is not a perfect square. 16, right? Okay, so there are 2. It is always best to use the largest. It saves yourself a lot of time. I'm going to do it both ways. Remember, I always use the largest. So I'm going to do the largest first. 32 is 16 times what? 2. And then using our process right here, that's the square root of 16 times the square root of 2. What's the square root of 16? So that's 4 square root of 2. Okay? 4 square root of 2. If you had said 4, this is what you would have had to do. So you'd say 4 times what? 8. So splitting it apart, you get the square root of 4 times the square root of 8, correct? What's the square root of 4? So I get 2 square root of 8. All right, so that's where I'm at. But we're not done because I can still simplify the square root of 8. What perfect square goes into 8? 4. 4. So it becomes 2 times the square root of 4 times 2, right? Splitting it apart, just like we did previously, that becomes 2 square root of 4, square root of 2, and this square root of 4 is what?
2.
And this 2 times 2 is 4, so you get 4 square root of 2. All right. It is, see how much easier it is if you use the largest. Use the largest. All right, now, let's look at number 3. I have -8 plus the square root of a -50 divided by 10. -8 plus the square root of a -50 divided by 10. Now you're going to see this expression when we solve quadratic equations at the end of the period. So it's going to look like this, and so you want to simplify that square root if you can. Can I simplify the square root? The answer is yes for several reasons, because there's a negative, and I know that the square root of a negative number is going to involve what idea? That I. And I know that 50, what perfect square goes into 50 besides 1? 25. So what I would do is I would take the square root of -50, just rewrite it, and then simplify it. So I'm going to use, see that square root of -50? I'm going to use this idea here, where we wrote it like this. So the square root of a -50, do you agree that's the square root of a -1 times 50? Which is the square root of a -1 times the square root of 50, correct? All right. Now the square root of a -1 is what? I. So we know that. Now let's deal with the square root of 50. What perfect square goes into 50? 25. All right, so do y'all agree that I can write this as I times the square root of 25 times 2?
Yeah.
and then splitting it apart, although some of you know the square root of 25 is just what? 5. So some of you can skip what I'm about to do. But that's I square root of 25 times square root of 2. And what's square root of 25? 5. Now there are a couple, we know that's 5, right? Okay, a couple ways you can write this. Mathematically, a couple of ways. You can say 5I square root of 2, where we put the I between the whole number part and the square root part. Or you can put the I in the outside, behind the square root. So 5 square root of 2 times what? I. Just make sure that the I doesn't look like it's under the square root. It's not this. Okay? Don't make it look like that because it looks like I is located where?
In the square.
Under the square root, and that's not true. It's supposed to be located on the outside. All right, so don't do this. That's not correct.
Now, well, right now on the worksheets and stuff like that, can we skip the step and just keep negative 25 and just keep it like that? So we can simplify it so we don't have to write the
Wait, where are you getting negative 25 from? Oh, you mean like this?
like the first.
Yeah, you
like
can
the
say
first-
negative 25 times 2.
Yeah,
Yeah,
okay.
no, that's fine. But you would have to at some point know that negative 25 is really 5I.
Yeah.
Okay. No, that's fine. All right, so then I'm going to go ahead and rewrite this 5 square root of 2 times I here. Just like this. Over what? 10. And then they're going to ask you to write it in standard form. So that's negative 8 over what? 10. Plus 5 square root of 2I over what? 10. Can I reduce anything?
Yeah.
Yes, I can reduce negative 8/10, which is negative 4/5. And then the 5 and the 10. Now, let me ask you this. Can I reduce this 2 that you see here and the 10? No, because that's not a 2. That's a what? Square root of 2. Square root of 2 is 1 point something. So you can't do that. But I can reduce the 5 and the 10. So 5 and 5 is 1. 5 and 10 is 2. So what's the answer? Square root of 2I over 2. All right, so that's what you get there. All right, let's look at this one. We're going to do one more with this. So this is number 4. Okay, number 4. You have negative 18 minus the square root of a negative 27 divided by 21. So negative 18 minus the square root of a negative 27 divided by 21. All right, so we have the square root of negative 27 we got to deal with. Now, if you don't look at the negative, just look at the 27 for right now. Besides 1, is there a perfect square that goes into 27? 9. Now, what Trey was asking is this. Can he write it as a square root of a negative 9 times 3 like this? Yes or no? Yes. And then he said, can he then rewrite it as a square root of a negative 9 times the square root of 3 like this? Yes or no? Yes. And then you know what the square root of a negative 9 is. What's the square root of negative 9? 3 what? 3I times the square root of 3. Or you can write it as 3 square root of 3 times what? I. It's up to you. His is probably a little bit quicker. Well, it is quicker. And for some of you, it's a little bit better to understand. But remember, the square root of a negative 9, we already did something like that a while ago. That's just 3I. So you get 3I times square root of 3, or you can write it as 3 square root of 3I. So that's this right here. So I get negative 18 minus 3 square root of 3I all over 21. But then they're going to ask you to write this in standard form. So in standard form, you're going to say negative 18 divided by 21 minus 3 square root of 3I divided by 21, and then you reduce. Negative 18 over 21, can I reduce this?
Yeah.
Yes, they're both divisible by what number? 3. So that becomes negative 6 over 7. Now be careful, these are both 3's, right? Except this one's square root of 3. So when I say they're both divisible by 3, I mean this 3, right? Not this one, because that's not a 3, that's a square root of 3. So that's 1 and that's 7. So what do you write here? I square root of 3, or you can say square root of 3, I divided by 7. Now you see how the I, when I wrote it in back, it looks like it's on the outside, so the square root of 3 times I. Don't put it close enough to where it looks like the I's under the square root.
But you did say it was okay for that on the other side of the.
Yeah, so you can say negative 6/7 minus I square root of 3 over 7. That's fine.
And that's standard.
Yeah, where you have A plus BI. All right, so that should take care of section 1.4. All right, section 1.4.